Hey everybody! Today we're going to be looking at this problem which says to differentiate the following function, and the following function is f of x equals integration 0 to x of x minus t cos t dt. And this is maybe a little different than what you guys are used to because you see that on the upper bound we have a variable x and not a concrete number like 1, 2, or even -1. So we have to apply a little bit of our brains here. But if you want to give this problem a go, please feel free to, and then I will walk through the solution. Okay, so hopefully you gave that problem a go. There is a new formula we are going to learn, and that has to do with definite integrals and differentiation. So we're kind of putting those two together. So here is our new formula, which we're going to call definite integrals and differentiation, and that states when a is a constant, the derivative of this integral, a to x, where a is a constant once again, is f of x. And this is probably a new formula, and we're just going to go over how we actually got this formula, because we had to get it from somewhere, right? So let's start off with a simple integrand. Let's say integration of a x of f of t dt is equal to f of x minus f of a. And hold on before you start saying, what? Oh my gosh, how'd you get that? Let's just assume that f of t is essentially what I'm saying. Let's let the indefinite integral of f of t be f of x. So basically, essentially what it's saying that, integration, oh my gosh, guys, integration of f of t with respect to dt is f of t. That's basically what it's saying. And then if you put values over here, say 0 and 2, then you'll obviously get f of 2 is equal to minus f of 0. So if that makes it a little easier, you could say f of 2 minus f of 0. That's basically what it's saying. So basically the indefinite integral of this f of t is equal to uppercase f of t. Now that we have that, the question asking us to differentiate, not solve this, but differentiate. So we have to do that. So let's differentiate both sides. So we get d over dx of this whole integral, a to x, f of t, dt, is equal to the derivative of this whole thing. Okay, and what exactly would be the derivative of this, right? Well, that's basically just f prime of x, we don't need it as that, minus f prime of a. We know that this will be a constant because a is a constant and the derivative of a constant is 0, so this is just f prime of x. And if we do f prime of x, then we know that that is just equal to f of x, because f of t, because the indefinite integral of f of t is this bigger case, f of t. So that's how we get the formula. We went from this, and then we went from this is equal to this, which is exactly what our formula states. All right, since now we know our formula, which is right here, we can go on to solving this problem. And once again, feel free to pause the video and try this problem on your own now that you know the formula. All right, so I'm going to walk through the solution with you guys. So we have to derivate this integrand. Let's first simplify this integrand. So we can say that f of x is equal to 0 to x, and let's just simplify whatever's inside. That's x cos of t minus t cos of t dt. Let's split the integrand, so we get 0 to x cos of t, cos of t dt minus 0 to x t cos of t dt. One thing to note, you can take this x out because it's basically a constant, right? Since we're derivating by t, x is not t. So this x doesn't really matter. We can just take it out and treat it as a constant. So we get x out, 0 to x. We have cos t left in here. And then we just write this the same. And this is all capital F of x. Now that we have this, we can't really simplify anymore. So let's start to derivate it. That's basically saying f prime of x is equal to, we have this, let's apply that product rule. So what we get, let's take the derivative of this, that's 1. We leave that the same. 0 to x cos t dt. Once again, I'm simply applying the product rule. Plus this and the derivative of this. 0 to x cos of t dt minus all of this. Oh, I'm running out of space. I'll write it down here. 0 to x t, the derivative of that, cos of t dt. There we go. Now let's start simplifying it. Let's leave this as it is since we can't simplify just yet. Cos t dt plus, now you see where the formula is coming in handy. We have this and we have this formula. They look extremely alike. So this would essentially be x times cos x when we look at our formula right here. Because we have the x, the a doesn't really come into play, right? We just replace x for that t and that's our answer, f of x. That's exactly what I did. This is in terms of t, just replace x, I got cos x instead of cos t. Now we're done with the derivative for this part. We still have the derivative for this part. Once again, same thing. This is in t, let's just replace the t for x. So we get x cos x. And that's the derivative. Now we can go ahead and solving this. We know that the antiderivative of cos of t is sine of t, 0 to x. And we know this and this cancel out, so that's what we're left with. F prime of x is equal to sine of x minus sine of 0. Sine of 0 is just 0, so we're left with f prime of x is equal to sine x. And that is our final answer. Now let's try solving this. Differentiate the following function once again. This time the function is integration 0 to x minus t, sine of t dt. And we have the formula right here. So yeah, feel free to pause the video and give this problem a go. Alright, I hope you guys gave this problem a go. If not, and you got a little stuck, I will go over the solution right now. So this is kind of the same thing as we did earlier. First, let's try to simplify this integrand. So we get f of x is equal to integration 0 to x. Let's expand this. We get x sine of t dt minus t sine of t dt. And that's all. Oh, whoops. I did that wrong, guys. Sine of x minus t sine of t, and then at the end it's dt. Whoops. Now that we have that, let's split the integrand so we get 0 to x, oh my gosh, x sine t dt minus integration 0 to x, t sine t dt. Once again, we are differentiating with respect to t, not x, so we can treat x as a constant and take that out. We get x out, and then we're left with integration 0 to x sine of t dt. And this one simply stays the same because there is no x here, so we can't take anything out. We're all differentiating in terms of t. So 0 to x, t sine t dt. Now we have simplified as much as we could. Let's start to take the derivative, since that is what the question is asking us to do. To remind you, here is the formula that we will be using. So before we can do that, let's first apply the product rule once again over here. That way we will get an expression in terms of this, and then we can easily solve that to get that f of x. So the only reason I'm applying the product rule is so that we can get an expression that we can apply this formula in. So let's take the derivative of that. That's 1 times integration 0 to x. This stays the same. Sine of t dt plus this and the derivative of this, which is d over dx. I'm going to run out of space again. Integration 0 to x sine t dt minus, and this whole thing is just going to be derivated. So we get minus the derivative of 0 to x t sine t dt. Now we can simplify this saying 0 to x sine t dt plus x. Once again, we put it in that formula up here. So this would essentially be equal to sine of x, because once again, if you're taking the derivative, just replace the t for x. That's a simple way to remember it. But only when you're taking the derivative. Don't replace t for x when you're taking the integral or antiderivative. That's completely wrong. And then you do minus, same thing over here. Replace the x for t since we're taking the derivative of this integral. X sine of x. And now, let me get a new page. Then we have, let's simplify this. So we get the integration of sine of t is minus cos of t 0 to x. This and this cancel out. We get, let's take the minus out since it's a constant, minus 1. So then minus cos of t 0 to x. We get minus cos of x minus cos of 0. And then we know that cos of 0 is 1, so that's where we get the 1. Let's simplify this, so we get minus cos x plus 1. And that is our answer. Alright guys, this is the last problem we're going to solve. And basically it's the same exact thing. Differentiate the following function, which is f of x is equal to integration 0 to x, x plus t, e to the power of t dt. Feel free to pause the video and give this problem a go. Alright, so hopefully you found the answer. If not, I'm going to walk through the solution. So like we did with the other problems, we're going to first simplify this integrand. So we get f of x is equal to integration 0 to x, x of x times e to the power of t, plus t e to the power of t, and then dt. Let's split the integrand so we get 0 to x, x e t dt plus integration 0 to x t e to the power t dt. Once again, x is just a constant because we're because we're essentially integrating with respect to t. So that's 0 to x. We have to take x out. 0 to x, and then we're just left with e to the power t dt. Plus, here we can't take anything out, so we just write it the same. Now we are ready to differentiate. We get f prime of x equals, apply the product rule once again. So 0 to x, e t dt, plus x, and the derivative of integration 0 to x, e t dt. plus the derivative of integration 0 to x t e t dt. F prime of x is equal to this, let's just leave it as it is, e t dt, e to the power of t dt, plus x from the formula up here. We can apply that over here now. So then this is basically e to the power of x plus, once again, x times e to the power of x. We can simplify this now. The antiderivative of e to the power of t is simply e to the power of t. 0 to x. This is equal to 2x e to the power of x. Another page. Now let's just simplify this. We get e to the power of x minus e to the power of 0 plus 2x e to the power of x. We know e to the power of 0 is 1, so we get minus 1 plus 2x e to the power x. Just to simplify, let's take this e to the power of x out, so we get 2x plus 1 times e to the power of x minus 1. And that is our final answer. Whoops. This is our final answer.